Hello everyone, welcome back to channel. In today's video, we are continuing with vectors part 3 from the NCERT miscellaneous exercise of chapter 10, and we will be solving problem 9 and 10. This so stay tuned till the end of the video. Follow each step carefully and note down the key tricks and concepts I will highlight along the way. Let's begin with problem 9. So we have problem 9 is find the position vector of a point R which divides the line joining the 2 points P and Q whose position vectors are vector 2 times vector A and plus vector B and vector A minus 3 times vector B externally in the ratio 1:2, also so that P is the middle point of the line segment, so RQ. So let's start this problem. So first of all, let's recall the formula for the external division. So in external division, the point R lies outside the line segment PQ but still on the line that passes through P and Q. The point R can be either side of the segment. So you can look here, you can see here that this R divides P and Q externally in the ratio m/n, and if you want to write the coordinates of the position vector of R, so you can write by OR vector is equal to m times OQ, that is position vector of Q, minus n times position vector of P, that is OP vector, over m minus n. So this is the formula for external division, and you recall that the formula for internal division is here in place of negative sign we have positive sign. Now formula for position vector of R, we have you can see here m times B vector minus n times A vector over m minus n. So using this formula we are going to solve this problem. So first of all, we have given position vector of P and Q. So position vector of P and Q are OP vector is given and OQ vector is also given, and we have to find out OR vector, and R divides in ratio 1:2. So we have given OP vector is 2A plus B vector. So OP vector is 2A plus B vector, and similarly OQ vector is A minus 3B vector. So this is A minus 3B vector, and we have given that R divides 1:2. So R divides P and Q in the ratio R divides P and Q in the ratio 1:2. So this is externally. So this is points P and this is Q, and here R. So R divides P and Q 1:2. So this is 1:2. So this is 2 times of OP 2 times of OP vector. So 2 times of OP vector minus 1 times of OQ vector. So 1 times of OQ vector over 2 minus 1. So this is the formula using this previous formula. Now we can write OR vector is equal to 2 times 2A plus B vector, and this is minus A minus 3B vector. This is 1 times, and over this is 2 minus 1 is 1. So OR vector is equal to 4A plus 2B vector and minus A plus 3B vector over 1, that is 3A vector plus 5B vector. So position vector of R is position vector of R is 3 times A vector plus 5 times B vector. 3 times A vector plus 5 times B vector. Now recall that formula for midpoint, formula for position vector of midpoint of two vectors C and D is given by C plus D over 2. So similarly we have to find out the middle point of the line segment RQ. So position vector of middle of RQ is given by position vector of R plus position vector of Q over 2. So position vector of R is given in the we have obtained here 3A plus 5B. So this is 3A plus 5B vector plus, and position vector of Q is A minus b 3b. So vector a minus this is 3b over 3 times b vector over 2. So this is equals to 4 times a vector plus 5 plus, so this is 5 minus 3 is 2 times b vector over 2, and this is equal to 2 times a vector plus b. So 2 times a vector is what? This is the position vector of p. We have given position vector of p is 2 times a vector plus b vector. So this is the position vector of point p. So this shows that position vector of middle of line segment RQ is position vector of P. Therefore, P divides line segment RQ in 1:1 ratio. So 1:1 ratio. Therefore, P is the middle point of line segment RQ. P is the middle point of line segment RQ. Thus, we have solved problem number 9. Now, let's move on the problem number 10. Before I am giving you a problem, similar problem for practice to apply external division formula. So here you can practice here and you can take screenshots. Now next move on the problem number 10. So we have given two adjacent sides of parallelogram are 2i cap minus 4j cap plus 5k cap and I cap minus 2j cap minus 3k cap. Find the unit vector parallel to its diagonal and also find its area. So first of all, we have given a parallelogram. So we can write here DC vector and AB vector, CB vector, and DC is, since DC is parallel to AB, so we can write here AB vector, and this DA is CB is, we can take DA is parallel to CB vector. Now, if we take write A is equal to 2i cap minus 4j cap plus 5k cap, and vector B is equal to I cap minus 2j cap minus 3k cap, and if we denote DC by vector A and denote CB by vector B, then this DC vector plus CB vector is equal to DB vector by triangle law of addition. So this is DB vector. So DB vector is a diagonal. So DC is what? DC is vector A and this is B. So A plus B is, after adding, this is 3i cap minus 6j cap and this is plus 2k cap. So this is DB vector. Now we have to find AC vector. So you can see here in triangle ADC, if we take this a vector from A to C, then DA plus AC is equal to DC. So in triangle ADC, DA plus AC vector is equal to DC vector, and DC vector is A and DA vector is B, and we have to find out AC vector. So AC vector is A minus B. So A minus B is equal to I cap, and this is minus 4 plus 2 is minus 2j cap, and this is plus 8k cap. Now we have to find out. So we have obtained the obtained vectors along the diagonals of parallelogram. Now we have to find out unit vectors. So unit vector along DB vector. So this is DB vector is equal to D vector over its magnitude. So vector is 3i cap minus 6j cap plus 2k cap over magnitude. So magnitude is obtained by the 3a square plus minus 6a square plus 2a square, and this is equals to 3i cap minus 6j cap plus 2k cap over, this is under root 49, and this is equals to 3i cap minus 6j cap plus 2k cap over 7. So this is the unit vector along, DV. Now we have to find out unit vector along AC vector. So unit vector along AC vector is obtained by the formula vector over its magnitude. So similarly, we can write here, we have AC vector is I cap minus 2j cap plus 8k cap and its magnitude. So its magnitude is 1a square plus minus 2a square plus 8 square. So this is equals to I cap minus 2j cap plus 8k cap, and this is equals to under root 69. So this is the required vectors along its unit vectors along diagonals of parallelogram. So first unit vector along diagonal is 3i cap minus 6j cap plus 2k cap over 7, and second vector is unit vector is minus 2j I cap minus 2j cap plus 8k cap over under root 69. Now let's move on the another part, other part of this problem. So we have to find out the area of this parallelogram using vector methods. So first of all, recall that area of parallelogram is base into height. So you can see in this picture, the base is BC and height is H here. So B into H is the area of this parallelogram. Now we have to use here vector methods to find out the area, and we have given sides, adjacent sides, in the form of vectors. So applying this, we have the formula vector A cross vector B. So now you can see here, you can understand here by this explanation. So if you draw the perpendicular from D to base BC and let this height is H and write this as M, so length of CD is magnitude of vector B and length of BC is magnitude of vector A. So area is equal to BC into H. So we have to the magnitude of BC is length of the BC is magnitude of A into H. So we have to find out H. So if angle between vector A and vector B is theta, so this is theta. Therefore, sine theta is equal to H over CD. So H is equal to CD sine theta, and CD is equal to mod of B sine theta. So what we have obtained here, area is equal to mod of A, and value of H is mod of B sine theta, and this is what? This is the mod of A cross B. So this is the required formula for the area of parallelogram. Now we are going to find out the area of the parallelogram. So let's do this. So area of the parallelogram is, we have given area is mod of A cross B. So A cross B is obtained by this determinant I cap, J cap and K cap, and we write here components of A and B. So components of vector A and vector B are, so vector A is 2i cap minus 4j cap plus 5k cap. So we write here, so this is, so right here components of vector A is 2 minus 4 5, and components of vector B is 1 minus 2 minus 3. So this is equal to I cap, and expanding this determinant, so this is I cap, this is 12 plus 10 minus this is J cap minus 6 minus 5, and this is equal to plus K cap minus 4 plus 4, and this is equal to 22 I cap, and this is plus 11 J cap, and this is 0 K cap. Now this is the A cross B. So this is the value of A cross B. Now we have to find out mod of A cross B, and this is the required area. So mod of A cross B is 22 square plus 11 square plus 0 square under root, and so this is equal to 484, and this is 121 plus 0, and this is equal to 605 square units. So this is area. Write this as, so this is equal to 121 times 5, so 5 root 11 square units. So we have area is, required area is equal to mod of A cross B, and this is equal to 11 root 5. So this is, sorry, this is calculated here, 11 root 5. So this is 11 root 5 square units. So this is 11 root 5 square units. Now thus we have solved the problem number 10, and I hope you have understood problem number 9 and 10. Now I am leaving with a similar problem for practice. You can check, you can take screenshots and try to solve with yourself. Now, I hope the session help you understand the concepts clearly and give you confidence in tackling similar problems. If you found this helpful, don't forget to like, share, and subscribe to the channel, and make sure to turn on the notification bell so you will not miss the upcoming videos where we will cover the next set of important questions. So, thank you. See you in the next video.